Hey everyone, it's Mr. Vargas here. Just looking to help out my Math 3 class with a few of the challenge problems from homework, in particular numbers 17 and 18 from homework 0.2. Here we go. Try to make this video nice and quick. Number 17 says, I'm thinking of two integers. One is 7 less than a number, and the other is 2 greater than the same number. So whenever we're talking about like some mystery number that we don't know of, we're usually talking about a variable. And the variable you choose doesn't necessarily matter, but typically we use x. So the first one would be 1 is 7 less than a number. So 7 less than a number is represented by x minus 7. So that would be the first number. And then the second number is 2 greater than that same mystery number. So we've got our mystery number, which is x, and then we just add 2 to that since it's 2 greater. So there you go. Now we have expressions for number 1, the first number, and the second number. Okay, write a polynomial expression for the product of the numbers. So this is where we're going to use that F.O.I.L method. We're going to take number 1 and multiply it by number 2, those mystery numbers, to get a polynomial. In particular, this is a binomial right here times another binomial right there. And when you multiply those out, you're going to get a trinomial type of polynomial. So just go ahead and do my little arrows. First, outer, inner, last. Thank you, Teddy. That's my dog just trying to say hello. So let's quickly do this multiplication. X times x gets you x squared, and then x times 2, so plus 2x. Okay, the next number is negative 7 times x, so this will result in a negative 7x. Do not forget about that negative sign. And then the last multiplication is negative 7 times 2 to get you negative 14. Combine like terms. Those two guys are the same. They have the same variable and the same degree. So we can rewrite this as x squared minus 5x minus 14. And that is the polynomial, which is a trinomial here, because we've got 1 term, 2 terms, 3 terms, to make it a trinomial. Alright, let's go ahead and move on to the next problem. Okay, in problem 18, we're told that Monica's current office is a square. So if I draw a square here, it's probably the best square that I can do right now. It's a square, and they don't tell us the dimensions of the square, so we can use a variable to represent the length and the width. And since it's a square, those lengths will be the same, so I'm just going to use x. Alright, but they do tell us that her new office in the company's new building will be 3 feet wider and 5 feet longer. So for part A, we can write expressions for the dimensions of the new office, and all we do is we take x for the one side, make it 3 feet wider, and we take that other side and make it 5 feet longer. So there we go, we've got the two new dimensions for her new office. Part B says to write a polynomial expression for the area of Monica's new office, and we can definitely do that using F.O.I.L. So x plus 3 is going to be the new side length, x plus 5 is going to be the other new side length, and we can F.O.I.L that out as we multiply to find area, side times side to get the product. Side times side equals the area of a square, or a rectangle in this case. Length times width, if you want to call it that. That's probably more formal for this rectangle. Let's go ahead and do that multiplication. X times x gets you x squared. X times 5 gets you 5x. 3 times x gets you 3x. And then last but not least, 3 times 5 makes 15. Combine like terms to simplify the polynomial, and you get 8x. when you combine those two like terms. Alright, so now we have a polynomial expression to represent the area of Monica's new office. Part C, probably the trickiest part. Suppose Monica's current office is 7 feet by 7 feet. Okay, remember that original office square. Okay, now we know it's 7 by 7. So first of all, I would figure out, okay, what's the area of that? You're just going to multiply 7 times 7. So that has an area of 49 feet squared on the inside. Okay, and then how much larger will her new office be? Alright, well, we've got that awesome polynomial that we figured out was x squared plus 8x plus 15. And we can go ahead and insert the old dimensions, because remember the x here represented the old dimensions. So we can plug 7 in here, 7 right there, and go ahead and calculate the area of her new office. So we're going to get, what is that, 49 plus 56 plus 15, and that means the area of her new office is going to be 120, if I'm not mistaken, 120 feet squared. 120 feet squared is going to be her new office. Unfortunately, though, that is not the answer, as we are asked a different question. The question states, how much larger will her new office be? So we have to compare her old office to her new office. Since we want to know how much larger it is, we can actually do subtraction, taking the new and subtracting away the old. So here's the new minus the old. And this will tell us how much larger her new office is. And there we go. Her new office is going to be 71 feet squared larger. It's going to have an area that is 71 square feet bigger than her old office. Alright, that's it for today. See you guys in class.